Eric Burgess here, and we've been told to solve the following equation. And so looking at this thing, first order of business is to combine as many of the like terms as is possible. So I'm going to go ahead and move this 9 over to this side because it can combine with the 7. And it also will isolate the radical, which is our goal. We want the radical all by itself so that when we square it, the radical simply goes away. So I'm going to go ahead and rewrite this. So we're going to have the square root of 6x plus 7 minus 9 plus 9 equals x minus 7 plus 9. These will go to 0. And we are left with the square root of 6x plus 7 equals x, and then 9 minus 7, that's 2. So that's plus 2. So, okay, we've isolated the radical. So now what we want to do is square both sides so that the radical goes away. So we go ahead and we square it like so. And we square this side. And we wind up with 6x plus 7. All it did was cancel out with the radical, right? And on this side, remember that whenever we have a square like this, like let's just say that this was a plus b squared, the pattern that results is a squared plus 2ab plus b squared. So we can use this to very quickly evaluate this. So a is x and b is 2. So this would be x squared and then plus 2, and then that's ab, so that's 2x. So 2 times 2, that's 4. And then we have x. And so I just did that 2ab plus b squared, so that's plus 4. Alright, so now that we have done this, let's go ahead and continue. So now we should get all our things on one side and 0 on another side so that we can do some factoring. So to do that, I'm going to do the opposite of what's on this side. So this is a positive 6x and a positive 7, so I'm going to do a minus 6x and a minus 7. And we're going to get x squared plus 4x plus 4. And again, for it to be equal, we have to do it to this side as well. So we did the same thing to both sides. So this is a valid move. It keeps the equality happy. And these will all cancel out and will go straight up to 0. And we are left with this equation. And then we could combine the 4x and the negative 6x to make negative 2x. And the positive 4 and the negative 7 to make negative 3. Now you can move things to the other side if you wanted to. The reason I moved them from this side to this side is because the x squared is positive on this side. And if I move the x squared over here, it would be negative. And then I'd have to divide out a negative. So I decided to save myself those extra steps and move to the side with the positive x squared. And once we get here, all we have to do is factor. So I'm just going to go ahead and factor this. So x times x. And then to get 2, we can use 3 and 1. 3 and 1. The 2 should be negative, so this gets the negative and this gets the positive. And this will factor out. We could check it. We could see that x times x gives x squared. And then we have x times 1. Well, that's just 1x. And then we have negative 3 times x. And then the ending negative 3 times positive 1 is negative 3. And these combine to give negative 2. So I probably won't check them like this as much in the future. I'm just going to kind of assume that you've got some factoring under your belt. You can also do the quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. You can do that as well. And if you have a calculator that can do factoring for free, you just type it in and it does it. You could use that as well. All right, so by the zero factor property, we can set each of these equal to 0 individually. So we have this. And then solving for x, we get x is equal to 3 and x is equal to 1, negative 1. But we can't quite stop here. So these could be the solutions, but because we're dealing with radicals, the radicals have a special rule that says that you must only have positive numbers under here. But we did is squaring, and what this does is it takes all the negative numbers and makes them positive, right? So it might make it look a little different than, we might get a solution that looks like a solution, but it's actually not because of this radical. So we have to go back and we have to check it. So we say, okay, we're going to just put these in the calculator. I'm going to put second square root, and then we're going to do 6 parentheses, and then our first x is 3, so I'm going to put down 3. Plus 7, and then out from under the radical, minus 9. What do we get? We get negative 4. Now let's check with this side. So we don't need a calculator for this part. We could do 3. So that's 3 minus 7. That's negative 4. So this one checks. It comes out true for both sides. Now let's go ahead and test negative 1. So I'm going to come up and just copy what I previously wrote. And we just need to put in a negative. And I'm going to insert a 1. So I just put negative 1 in. We get negative 8. And if we put negative 1 in up here, negative 1 minus 7, that's also negative 8. So this one checks as well. So we could say with confidence that our solution set, x, the elements that are part of the solution set are 3 and negative 1. It doesn't matter what order you write them in for the final answer. And that's it. That's how you do one of these. If you have any questions, feel free to drop them in the comments. If you're a Citrus College student, feel free to stop by online tutoring. We're there to help you out. Subscribe, and we'll catch you in the next problem.